So we looked at some graphs for quantitative data in 2.2. Most commonly used was the histogram. But there's other ways to display your data. Now, stem and leaf plots are a simple way to display small data sets. If it's really, really large, a histogram put into classes is a lot more convenient than a stem leaf plot. So let's talk about a stem leaf plot. In a stem leaf plot, the rightmost digit is the leaf, and the remaining digits form the stem. So here we have a table presenting the U.S. Census Bureau projection for the percentage of the population aged 65 and over for each state and the District of Columbia. So the rightmost digit would be our decimal place. So that's my leaf. The stem are the first two digits here. So the rightmost digit, which is our decimal place, is so example, Alabama. The stem is 14 and the leaf is 1. So the way we do this is we're going to go through and we've got all the stems listed in order. So we got the smallest stem all the way to the largest stem. And we're going to go through our list, and for each value, we're going to write the leaf next to its stem. So, for example, Alabama is 14.1. So we're going to put a 1 next to 14. 14.3, so I'm going to put a 3 here. 14.4. 17.8 is the next value. So 17.8. 12 would really mean 12.0. So I'm going to put a 0 here. 14.9. 12.6. 13.7. 12.8. 13.8. 13.7, 12.4, 13.8. And notice I'm kind of lining up these leaves kind of in columns. Next one is 14.1, 13.3, 14.3, 16 would be 16.0, 8.1, 11.5, 14.1, 10.2, 12.4, 13.4, 15.6, 12.8, 13.9, 12.3, 14.1, 15.3, 13, 13.0, 13.6, 10.5, 12.4, 13.5, 13, whoops, that's a 5, 9, 10.7, 11.5, 14.3, 12.7, 13.1, 12.2, 12.4, 15 would be 15.0, 12.6, 13.6, 13.7, 15.5, 14.6, 9 would be 9.0, 12.2, and 14. Now, you could rewrite them in order if you wanted to, but we get our pattern. And it's almost like doing the tally marks when we're doing the histogram. If I turn this, it almost looks like a histogram. I can see that my 13 class or stem has the most, so that's the mode. And I can see that it's fairly symmetrical. We're kind of at a mirror image here, so that would be fairly symmetrical. So when you have a small data set, you can use this as a quick way to get an idea of your data. Now, sometimes we want to compare two data sets. And if they have values similar enough so that we can use the same stems, we can have a back-to-back stem and leaf plot. So we have course averages in an English class and a history class, and we're going to compare them with a back-to-back stem and leaf plot. So history is going to be on this side, English is going to be on this side. So these are our stems. So that's our first digit. The second digit would be our leaf. So 45, 68, 74, 81, 57, 69, 76, 83, 62, 72, 77, 85, 66, 74, 79, and 91. Do the same thing for the history class. 59. So notice I'm putting the leaf over on this left side. 71, 82, 92, 61, 73, 83, 97, 67, 80, 85, 98, 71, 82, 88, and 100 would be 10 with a leaf of 0. So I can kind of look at these and get this feeling of what's going on. We got this back-to-back data, and I can see that the English class has a mode in the 70s, and we have a mode in the 80s for the history class. So we know that overall the history class has higher grades than the English class. Now, the next one we're going to look at is called a dot plot. A dot plot is a graph that can be used to give a rough impression of the shape of the data set. It is useful when the data set is not too large and when there are some repeated values. This would be no good if things weren't repeated. And you'll see why in a second. So consider the number of children had by each of the presidents of the US and their wives. So we have some repeated data. What we're going to do is put a dot for each of the values. And we're going to put the dots going up. So 0, 4, 2, 2, well, 5 would go in between, so I'll put that there. 4, 10, 3, 2, 2, 2, 0, 5, 3, 4, 3, 4, 6, 6, 2, 4, 2, 6, 7, 2, 0, 2, 4, 0, 0, 1, 0, 1, 5, 8, 2, 4, 3, 6, so 4, 3, 6, 15, woo, 3, 5, 3, and 6. So looking at this data, we can tell what the mode is. And we can tell that this is not symmetrical. We have a right tail. So this is skewed right. And it's skewed right because we have these crazy people that had 10 kids and 15 kids. These kind of look like what could be called outliers, and we'll talk about that later. But a dot plot gives a good indication of where the values are concentrated and where the gaps are. For example, it is immediately apparent that the most frequent number of children is 2, and only 1, 2, 3, 4 presidents had more than 6 kids. And we can see that really clearly. So when you have a small amount of data, stem leaf and dot plots work pretty good. Now, the next one we're going to look at is called a time series plot. A time series plot may be used when the data consists of values of a variable measured at different points in time. In a time series plot, the horizontal axis represents time, and the vertical axis represents the value of the variable we are measuring. So we have a table and a time series plot displaying the closing value of the Dow at the end of each year from 2003 to 2016. So notice we have the years, then we have the values, and we can watch this plot and see what happens. And we see that the average declined, and then it increased again between, well, it increased from here to here, and then again increased from 2008 all the way up to 2016. So you can see that really clearly. Now, for a time series plot, you can plot it by hand, and you can also plot it in the calculator. So in a TID4, we would put the value, so again, this is under stat, under the calculator. We'd put the time, or the X values in L1 and the Y values in L2. And this time we would select, we could select the dot plot or the connected dot, and it would give me the same picture. So this could be done in the calculator as well. So that's a good thing to note. Now, just a note for our case study. If you chose to do a stem leaf plot for those, that would work as well as a histogram because we have a very small data set. So just a note there that you could choose to do a stem leaf plot or a histogram for the case study.